Hello, welcome back. We've got another little review going on here. I do love doing these types of videos as it does give you a good insight to how far you've progressed, since when you first started. It's a really good way to keep track on things. And it's a good thing to share what failures I've done. Hopefully you don't make them in the end. See what's wrong, what's right. But as you're probably looking at these, I'm going to go over some few. So let's get into it. I'm looking down here, I've got a few notes here. So let's start with the schematic. First, I should probably tell you what this board is. There's a breakout board for a microcontroller, simple one, MSP 430. I believe it's by TI. So one of these are like capacitive touch sensing ones that has the ability to. I haven't played around with capacitive touch, so it would be quite interesting. Well, let's get into it. Schematic. Title could have been provided. So as you see from the gas sensing project, I did have a title for each one of these, so you could tell already this is quite an old design that I have done. So title could have been provided. So usually I place the title up here, what this board is, what is it doing. Maybe I could have placed an overview page, and that would have given the user who is reading this, the engineer, what is this schematic about? What is it? What is he or she looking at? Spacing between components could have been laid out more effectively and neatly. So as you can see here, everything's a bit jumbled up. Really, it's all laid out. The IO is here, and what you need for the micro is over here. But what I was saying is that usually, like I said before, I would usually have these things boxed up and put like IO connector headers, MCU, things like that, or just Crystal have a net labels. That's another thing. I could have really just put net labels instead of ports everywhere. Could have would have been able to straighten out these lines instead of having all these kinks everywhere. It's really untidy. We'll get more of that into a second. And as well, another point, I could have really changed the schematic sheet size from A4 to A3. So this is an A4 size, I believe. There's nothing really stopping you from making it A3. Could have made two separate pages if I really wanted, but it's just a very small schematic. But at least really should have boxed it all up to know what everything is looking at. Could have put the calculations here for the stray capacitance if really need be. I think this might be a new thing I might start implementing to calculate these things, especially if it's a not crystal that I usually use. Might be worth putting it in there, see if it works or not. Brings me on to my next setting. So the labels could have been added, attaching text for what the component is, what are the headers for, simple now explaining the switches, which is explained in the data sheet. So this switch over here, it is used to, depending on what you're targeting, it was said labeled in the data sheet. Made a note here, which is good. Make connection J1 if local target power supply is used, or make connection J2 if target power from the debugger programming adapter. So depending on which one you put in, you have to reconfigure it. And I should have put this information provided in data sheet so people know where to find it. If I look back at this and thought, do I really trust? But it's in the data sheet. As I said before, I could have left the stray capacitance thing here, the calculations. Coming over to here, you can see all the tweaks and grids and things, such as grid settings were off, and look at that. God, that is horrible. Just the grid settings were off. As you can see, there's slight variations like here, just these things. Here's probably the worst one, these type of things, and you can't get it straight really because of the grid. So if you design a component within a selected grid, stick to that grid when you do your layout and your schematic and so on. Sorry, just your schematic. Layout, you can be a bit more flexible and so on, like so. Could have added net labels and such to crystal power lines to make it visible when routing. So this one is a common one I did miss out when doing these things before, is not putting certain net labels on, so what these lines are for, what this is line for. And again, so when you come to routing, it makes it much easier, or else you're just going to get something like, I don't know, net 21x_x12, something like that. It will also generate some label for you, but if you put a net label here, then okay, this is a crystal line. I need to be wary. I do not want to put any lines going underneath it, or try put some spacing between this for my guard trace. Components were not made and took off Altium, missing a crucial solder mask layer with some components. I'll get to this more in the PCB, but these components were took off Altium's manufacturer part search. If you do not know what that is, Altium has an inbuilt manufacturer part search over here where it just gives you a whole load of items that you can look for, and has models and so on and so forth, and they take it off. The thing is Octopart, gives you a data sheet, and so you can click here, you can see are these items in stock at these vendors, and you can just look in through and see what they have. It's quite useful. I quite like it. It's a nice little reference thing, and especially if you get the bad habit of just dragging and dropping, because look how easy it is. So you can just right click place, and there you go, your symbols there. It's got some information, it's got some description, I'm presuming the part number. It's got a footprint, a 3D model in most cases. It's got some details about the component. Everything's just so nicely done, until you realize that your part is wrong, that it's not in the grid settings you use, and the pins are wrong, and it's not like the same layout, whatever, the way you make your components, if you get what I mean. and it just looks like a jumbled mess. So it's good until you actually think, maybe I shouldn't do that. What I mean by this is actually when I came to making the board, there was a layer that was disabled. It was the solder mask layer, and every time I kept trying to like place the order, just like, oh, this is missing. I was like, oh, what is missing? What is missing? I don't really understand. Kept going back, placing it down, and I realized it was disabled, and I thought, oh, well, this is bad. I need to actually enable this or place it down myself. So this is why when you come to make your component, some things are just not what it seems and might be missing. So you're just rather better off making the part yourself. Last but not least, resistor value. I'm sure this one was staring everyone right at the face. There's no value for this. This is just a part number here. Really, this shouldn't be the case. And of course you can see I've took this off the Altium content vault, as you can see here. And this is why I just forget to change the part. See, here's 47 ohm. And for those of you that say, oh, that's a pull-up, will 47 ohm will really work? But in reality, this should have been 47k, and I really should have double checked it. But hey, at least you get a nice 3D model with it. Let us go into if that covers everything for the schematic. And that all makes sense. It was just a simple thing. Let's go into the PCB. So I wanted to give a summary, instead I'll do the PCB in the next video. A summary of this board so far. For the schematic, the title could have been provided, so with your boards, do provide a title or something to indicate what this part, what this section is doing, as shown previously. Spacing between components can be laid out more effectively and neatly, so if you have the space, do play around with it, do get them out, make it easier to read. Don't try and squish everything into one area just because you can. If you have the space, use it essentially. Change the schematic size sheet from A4 to A3, better to have more space than squeezing everything in. So I used an A4 sheet, and like I just said before, you can change it to A3. If you have the space, use it. I could have also made it a 2-page schematic really, or project, because I could have had one for the MCU and one for the headers. Labels could have been added attaching text for what the component is and what are the headers for. So this could have been the net ties to the crystals and so on, as I mentioned previously. Have net ties to make it easier for routing and to what this line is actually doing. This is indicated when you're doing to the PCB layout, or else you just get a randomly generated thing, and which makes no sense to anyone. The headers could have been a little note prior to why are they there, or what the switch was really, because this information was found in the datasheet. So there was a note there, but I think it could have been a bit more clearly labeled, or where was it found. Grid settings were off, and you get the little kinks and everything. And this makes it really look amateurish, and it doesn't look too fancy anyway. It's not really what you want. It just looks painful and messy to read. I've already mentioned the net labels and such in the previous lines, so I'll skip over that. Resistor is missing a value, so instead the component name was there, and or the part name should say, and this should have been the 47k for the resistor. The components were not made and took off Altium, and what this has resulted was a missing solder mask in between the component, and this had led to me having problems, but JLC PCB was gladly to pick those up and relay it back over to me, saying what needs to be doing. If this had been printed without a solder mask, I believe it would have been very hard to solder, or impossible to do so. Well, I mean that it'd be impossible to solder, or impossible is that it's there to prevent the parts joining up together. So if you had a pin, it might just all bridge across, how the component might just spread all over, and this would be very difficult to get an actual decent solder, or you just wouldn't be able to solder at all.